One really advanced notion in collections that you should make a habit of using right away is getting past this what's in the box collection. You see, by default, we don't know what's in a collection. Collections are built to deal with object, java.lang.object, where it could be literally anything inside of there. It could be a string, could be a capital I integer, could be a Boolean, capital B Boolean, could be any object you created, could be another collection, could be anything. We want to know what's in there. At best, if we use it this way, we have ugly code. At worst, we could end up with very error-prone code because we don't know what we're getting inside of there. It might just blow up at any given time. So consider this code real quick. I could go to a collection, and I could add in a string, and I could add in an integer. Capital S string, capital I integer. Nothing illegal about this. I go and loop through this code. I think this is full of strings. And so I go and say, well, this value O, take it and turn it into a string. And then I can say the length of the string is this many characters, because that's maybe the functionality I want to have inside of here. And when I do this, I get what's called a class cast exception, because I can't take a number and turn it into a string by default. I can convert it, but I have to intentionally do it so. I can't just say, oh, you're now a string. I certainly can't take a string and magically turn it into a number. I can't take a person object and magically turn it into a string. Or more importantly, a number and magically turn it into a person object. I need to be very explicit in my casting inside of here. So if all I ever deal with is a collection where I don't know what goes into it, and I'm allowed to throw any object into it, then I can easily end up with these type of class exceptions just on mistake, just by accident. And so Java has this mechanism called generics. We're not going to code it much. It's something you can code yourself were you interested in learning about this, but we'll see it in action here within the collection, map, list, all these different collection hierarchy classes. Because the way it works is I can define a class defined here by E that allows me to only add specific values. So I can only add strings. I can only add integers. I can only add a sales representative object as you'll be building in this class. And if I attempt to add something else, forget about not working. It won't even compile. It will tell you at compiler time that you can't add that thing inside of there. So when I create a string, a collection of strings, you see collection of type string, the generic lets me say this collection only contains strings. I can add in a new string. I cannot add in an integer. It gives me a compiler error now of string cannot be applied to the given type. String found. You're trying to give it an integer. So at that point, I don't even have to cast any longer. So instead of having an object here, like if we go back, you can see I had object O here and I have to cast it into a string. I can define the left-hand side here as being a string, and I know everything coming out of that is now value named string instead of some sort of object O. I can clean up my code. I can make it much more intentional to what I want it to do, what I was intending it to do, and I can turn runtime errors into compiler errors. So there's a ton of value in using these generics. You've probably seen them already a little bit, maybe didn't know what they were. You don't have to use them per se, but Code Complete will give you some advantages to put them in there, and all the demonstration code will be using them. So remember that and apply that as you're going off and writing your code as well.